Hello there. Today we are going to start a class called Propositional Logic and Rule of Interface in Artificial Intelligence. It is a series of videos in artificial intelligence, and this is the new one which is going to add it in the playlist for today's one. Let me take out my pen please, and then we'll move on to this one. Now, what is propositional logic? If you say it, it is just either true or false. Today is Sunday, it's true. Sun rises from west, it's false, and it's fall propagations, correct? 3 plus 3 is 6. Preposition logic is used some properties about facts, some basic about fact. It uses for Boolean values. It can use for true or false. It logical object. It's a relationship. A proposition consists of object, relations, and functions, and logical connectivities. These connectivities are called logical operators. Connection based on logical operators which are of two sentences, two or more sentence, they are connected with the logical operators. We A proposition formula which always a true is called as topology based on the valid statement or based on facts, and preposition formula which always false, we call it as contradictions. And preposition logic cannot be a commanding which is where is Rohani, how are you, what is your name, and everything. That cannot be a preposition logic. So basic thing in preposition logic, it's true or false and two or three valid sentences, and it can able to explain you what you mean by topologies and contradiction. There are two type of preposition. One is atomic preposition and compound. Atomic means there is only one sentence. 2 plus 2 is a 4. It's a true statement. Sun is cold. This is false. Only one statement comes up. Compound preposition is the combination of two or three sentences. It's raining today and streets are wet. This is one statement, and this is second statement. Ankit is a doctor and his clinic is in Mumbai. So there are two sentence combined, two or three sentence combined. We call it as a component preposition, whereas here we call it as atomic preposition. Then there are something of summarized table of preposition which are this is and, which is denoted by this one. This is or, which is denoted by this one. This is implies, A implies B. This is bidirection implications, and this is negation, correct? These are summarization and just a truth table of few I have just mentioned here so that you can able to understand it. True, false. If it is true, the negation is false. If it is false, this is true. And this is, if both are true, then it is true, otherwise it's false. If anyone is true, it is true, otherwise false. Implies, P implies Q. Sorry, it based on Q values, correct? Is based on Q values. So we will see it all those things in this one. Now there are some what you call properties of operators. There is community, P intersection Q or Q intersection par is same. Associate properties, that is P intersection R, then bracket open, then bracket close into R, we'll get this one. That identity element, that is true. Distributed law, De Morgan's law, and double negations. These are the properties of prepositional logics. That is community property, associate properties, identity element, distributed, De Morgan's, and negation. What are the disadvantages? We cannot use for all. Relationship, some one and one. All girls are intelligent. Some apples are sweet. I need to buy few, like few fruits. That cannot be identified in prepositions. Okay, I'm sorry, I'm saying that I can say all boys are also intelligent. All boys and girls are intelligent. Few boys and girls are intelligent. Few boys and girls are intelligent. So based on that one, I can able to say these are the limitation of prepositions. Now let me see the rule of interface in artificial intelligence. The rule of interface in artificial interface intelligence, we need to have smart computers. Why we need to have that can build on logic? That can build on logic from old logic or evidence. We have to build a computer based on evidence, based on rules, based from the fact, Interviews are the templates, that valid argument. It gives you the templates which are valid. Proof, We can say that these are the proof that based on that one we can able to identify. Now if I say x is equal to y, yes, x is equal to y is equal to 5, yes, both are valid statement. Now if I say x is greater than or equal to 5, means it cannot be 1, it cannot be 2, it cannot be 3, and it cannot be 4. It can be 5, and whatever the value, both 5 to infinity, correct? But these are my rules based on that facts I have created. If I say y is greater than less than or equal to 5, it can be start, or less than, or if I say y is equal to y less than or equal to 0 or 5, yes, 5 less than or equal to 5, it can start -1 or it can go till 5. So these are the boundaries, which are the facts which I have to show. So there are some rules which are being identified, that implication. If one of the logic connectivity denotes by the letter P and Q, the Boolean expression can be precise. Now the conversation implies is based on our left hand side. Converse implies in whatever the right hand side statement is applied to the left hand side. Contraposition is the negation of whatever the statements I have. Negation of P implies negation of Q. Inverse is nothing but inverse the authentication. Whatever the values I have got, inverse it. Now first let me go through this one simple statement. P negation Q, Q negation P. Now true, true, true. Now remember this one, I'm just going based on my left hand side. If it is false, this has to be false based on my left hand side. The conversation implies is that when your right hand side statement is applied to the left hand side. Sorry, this is my right hand side and is applies P implies Q. My right hand side is implies to my left hand side. This is false, this statement becomes false. This is true, and both are false, means what happens? What is the statement here? Why? If both are false, conversation in Boolean values which you can able to take it. Now other one is here the same thing. P implies Q, the same thing implies here, because I've just got if P Q, then this implies here. And if both are false, might be any conversation that have given the values. If I'll just give you an example when I move to the next slides. Now rules, that is modus ponens. One ponen is just Latin word, or you can just use that one. One of the most essential law of interface is modus ponens, which start with P. P implies Q, and if both are true, we can interfere. Q is also true, as well as written as like this. If P implies Q, then I can write P is true, therefore P is also a true, correct? Now the statement which says both are true and this is true, and both are false, that becomes also true, correct? Both are false, then it becomes false also. That's the statement which is given here. Now if I am sleeping, then I'll go to bed. This is my P. If I am sleeping, that is my P, this is Q. So if both are true, then I'm going to true. So both are true, I'm just going to P implies Q. If both are false, I'm not sleeping, I'm not going to bed, P implies Q is also true, because both the statements are I'm not sleeping, yes, that's P, and I'm not going to bed, that becomes true also. So hence we can say if P implies is true, P is true, Q is also be true, anyone can be true. So this statement is said. This statement I just explained you with the help of an example here. Correct? Modus ponens, which is very important part of it. If we can say P implies Q is true, either it is P or it may be Q. Correct? If it is both are true. Then another formula come up, modus tollens. According to the modus tollens, if P implies Q is true and negation is true, then negation of P will also be a true. Now sorry, if P implies Q is true and negation is also of Q is true, then we can say negation of P is also true. That's a simple statement. I am sleeping. If I am sleepy, then I'll go to bed. P implies Q. If I don't go to bed, negation of Q, which interferes that I'm not sleepy. Correct? If I'm not sleepy, I'll not go to the bed. So that is what a sentence said. So this is what the operation give us the values. This is modus tollens. Other one is hypothesis. According to hypothesis, if P implies Q, R and P implies Q, then is P implies Q or which says that P implies R and P implies Q, Q implies R. That is this both. We call it as associate properties also, which we have learned in DBMS. Now can be represented with the following notation. Example, if you have a home key, then you can unlock my home. Statement of if you can unlock my home, then you can take money. In other words, if you have my home key, then you can unlock them. If you can open to unlock my home, then you can able to take my money. This is what the time. This is what the truth table says it, and this is what the statement says it. It's just a simple associate rules. If A implies B and B implies C, we can say that B implies C also. Correct? Which is nothing but your associate rule. The same thing, if you have a home key, then you can open a statement where then you can unlock my home, then you can able to take my money. This is what the statement is. Now the other one is disjunction symbolism. What is mean by disjunction symbolization? If a rule is that if P or Q, P or Q, what is this here? P or Q, correct? P or Q is true, the negation is also true, then Q is also true. The notation, if P or Q is true, then P negation. Now let's take example. Today is Sunday or Monday. Today is Sunday or Monday. Today is Sunday or Monday. Today is not a Sunday, negation of P, and today is Monday. Now if I say what are you going to have it, I'll say I'll have anything like a garlic bread or a pizza. So what are you going to have it? There are two options, garlic bread or pizza. I'll have this, but I'll not have that. I cannot have both at the same time. So we can have the negation of truth. The truth table says the same thing, correct? This is called disjunction symbolism. We are going to solve the problem based on this one in our next video, which are going to come down. Then we have got additional, that is, if P is true, then P or Q is also true. If P is true, PQ is also true. Then notation simplifies this one. Negation of true, negation. Sorry, this should be like this. If I'm wrong. No, this should be like this. Correct. We'll see that. Notation. Now let's move on to this one. I have a vanilla ice cream. I have a chocolate ice cream. I can have either vanilla or chocolate ice cream. I can have either vanilla or chocolate ice cream. This statement says the same thing, correct? Now I have got simplification rules. Negation of P implies negation of Q is equal to this one, and this is the truth table for this one. P true, 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 false. Based on this one I have to take it. This is true, true. Based on the Q always implies it. Simplifies. Rule say that if P negation is true, then Q V will also be true, correct? So this is one statement. And then resolution is something like that, where we are going to solve a problem. On that one is called Wempus problem, and we are going to see all these rules: rule number 1, rule number 2, rule number 3, rule number 4, rule number we'll go back to this one and this one, which says that if this is true and this is also true, we can say P negation of true. Now see it, if it is true, P negation, this is also 1. What does it mean? If this is true, this is true. If this is true, this is true. And this is true, this is true. This is true, this is true. And look at it. If it is true, this one, this is also so. So based on this one truth table, you can able to go through this one. So there is a topic call which we have gone through. There are some rules which are there. Types of interface rules. That is Modus Ponens. That is Modus Tollens. Then hypothesis. Then disjunctive symbolism. Then we have got addition, we have got simplification and resolution. There are some rules, and there are preposition logics, which we can say this one. In today's class we have seen something about preposition, we have seen something about rules. I'll stop it here. Thank you very much.